All right, good afternoon, everybody. We are about to start. If you're just joining this channel for the first time, then I'm just asking you to click on subscribe or like the video right now. So like the video as well as subscribe to the channel if you have not yet subscribed. All right, so today we're going to start exactly on time. It's now 6:01. That is 1 minute extra. So we're going to be starting now. We're looking at performance tasks. And as you could see, based on what you probably have been doing in class, you would have realized that the performance task is like very different from your, ability tests and even your curriculum-based tests. This one requires a lot of thinking, a lot of critical thinking. You want to put together your ideas, put together your solutions as you go forward. One of the biggest things is that you must at all times keep reading the general information that you're given, making sure that you are understanding what the problem is about, and ensure that your calculations are accurate as well. All right. So what I'm going to do, I'm going to go through some problems and we're going to take some time to really unfold these ideas. So our first problem, as you could see here, it's dealing with a metal block, right? So I'm going to read. It says here that, so part A, the diagram below shows a building metal block owned by Nikoi with the following dimensions. So it's a 2 centimeters long, 2 centimeters wide, and 2 centimeters high. All right. So as you could see, you're looking at the block right here below. So we're looking at the block itself right here. All right. So the block is actually right there. All right. So the dimension it's giving, and we're looking at the block. Now, first, there are some questions that come. So we want to take some time to look at these questions. Very simple questions. And the questions normally go in terms of difficulty. So in increasing difficulty as you go on to part B, part C, and if there's possibly a D part to it. So we're at part A, and we have 5 little parts to respond to. So the first question says, how many faces does the metal block have, right, or has? So we want to look on how many faces this metal block has. The faces would actually be the surfaces that you can touch. So if you imagine rubbing your hand all over this block, what are the faces that you're actually encountering? So I'm going to try to mark them so you could see an idea of what I'm saying. So this is one of the faces right there, this one here, and it has a twin on the other side. Look at it over there. So that's 2, putting those in red. Some of my lines will overlap, but you could see those 2 at the side. I'm going to try to use a different color to highlight. Let me use blue. So I'm going to highlight the ones at the back. For example, look at that in the back, right? In the back of the screen there. And that one, that's number 3. And there is a 4th one, which is the twin for that one. It's at the front as well. So if you look at the front and at the back, so when I say the front, I'm referring to right here at the front, and then all the way around the back, you'll see 2 more. So that's actually 4. Looking at the faces that you could actually rub your hand over. Let's use another color. I'm going to use maybe green to show you 2 more faces. Look at the one that it is sitting on at the bottom. So this is number 5. And then look at the top, the exact top. Then you're seeing number 6. So when you really look at this, you're realizing that looking at the 3 shades that I use, the red, the blue, and the green, the number of faces it has, it's actually 6. All right. So we're looking at 6 faces. All right. So remember, the faces would be the surfaces that you could rub your hand over, whether it is, in this case, it's flat. All right. So flat surfaces, we're looking at 6 of them. Part B says, how many vertices, all right, the metal block actually have, right? How many vertices? When we're talking about vertices, you're talking about the little bulgy points, the little spots that are actually bulgy. If you know the answers, you could respond to them, right? So I'm going to clean back the diagram just to point at the vertices. I'm going to put it in green right now. Vertices 1, vertices 2, vertex 3, 4, 5, 6, 7, 8. So when we're referring to the vertices, you're talking about those little corner spots. And by definition, where you have actually the edges meeting up, right? So where the edges meet, you actually have what is called a vertex or plural vertices. All right, so we actually see that we're looking at 8 vertices, 8 vertices. Let's mark it, 8 vertices. And then now let's take that off. The next question is asking for the edges. How many edges are we looking at? When 2 faces meet, we get an edge. So I'm going to mark off the edges for us as best as possible. Let me try to be neat here. So I'm going to take down this. So this is edge 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you realize that we're seeing 12 edges right there. All right, so we have 12 edges right there. And if you intend to draw this shape, the lines that you actually draw, those are actually the edges, right? So we actually see that we found that we actually have 12 edges right now. All right, moving along. What name, all right? We want to know what geometric name can be given to the metal block. So I'm going to wait to see those who respond. All right, I'm waiting to see those who respond in the chat. Remember, if you're just coming in, please like the video. And if you have not yet subscribed to the channel, subscribe to Daily Maths Concepts. All right, I'm waiting to see if there's anybody that wants to tell the answer to this D part. It says what geometric name can be given. All right, so I'm seeing Javon Green saying a cube. Yes, sir, the cube is correct. Alea Warren, I'm seeing a cube as well. So many persons. Louis, cube. All right, very good. So the answer for this, that this is actually a cube that we're dealing with, right? So now the questions are going deeper now. All right, so we just identified what solid we're dealing with. We're dealing with a cube, right? And all cubes would have the same dimension, right? So you're looking at a 2 by 2 by 2, that tells you it's a cube. A 2, 2, 2, all right? So the dimension is the same, so it goes all the way around like that. So now the next question says, calculate the volume of this block, all right? So I want to see some measurements coming out now. You are asked to calculate the volume of the block, all right? So if you have a cube, the volume of a cube is simply multiplying, it's one number, right? And by right, we're looking at, in this case, you're looking at, generally speaking, you would have said length times width times height, depending on the shape that you're dealing with. So we're talking about calculate the volume. The volume is going to be a 2 times 2 times 2, and you're looking at 8 cubic centimeters. And remember that you have to use the appropriate unit. All right, when you talk about volume, the unit of measure is actually cubic measurement. So to the 3rd power, look at this, we have to raise it to the 3rd, right? So we can't let it look like it's area we're talking about creating a 3-dimensional idea. So it's definitely a 3rd power for that. Very good. I'm seeing a lot of persons putting out the correct answer there. Danisha White, yes. Summer Morgan, a lot of persons putting out some very good answers there. All right, let's go further now to see what else is it that they're really referring to here. What else are they referring to? All right, let's look at part B. So we're now in part B, right? We're in part B. So what part B is dealing with? Part B says that Nikoi decides to use his metal block to build the block below. So he's going to take the block that he has, and if you look, I'm going to blow it up so you could see it right here. This is his block right here, right? So that's his 2x2 block right there. And we're going to be using his to create another block below that you're looking at in blue. So he's going to use his to make this, right? So he's going to put it together like building blocks, putting them side by side to create this other one. So now we want to put a little thinking in it now, right? So we want to think about how he's going to do it. So you're seeing here that they have layer 1, and it's telling you that is the bottom layer. All right, so it's going to be the bottom layer here we're looking at. So they actually insert a few here to show you that he's going to be building it like this. So he's going to find out the bottom layer based on the measurement that you have here. So based on these measurements that are here, he's going to set up the bottom part, and then he's going to go up with it up to that height overall when he builds his, right? So we want to know now, what is the name of the new solid he will build? So the new solid is in blue. You're looking at it. Yes, I'm seeing some good answers coming out. Very good, very good. So we can't say cube anymore because we're seeing difference in the dimension. So the moment one dimension changes, and it looks like a cube, no, it's now a cuboid, right? It's a cuboid. And there's another name for it, you know. I would like to know if there's one other person could tell me another name that this has, right? There is another name that all cuboids would have, another name. Let me see if anybody could respond to it. So it is called a cuboid, yes. And there is a second name that you could have called it, right? I'm waiting to see if one other person could give me another name apart from saying a cuboid. What other name you could have said and you are good to go? Waiting. Anybody want to jump in? Yes, I'm seeing some answers coming out. Exactly. So instead of saying a cuboid, we could have said that it is a rectangular prism. So that's another name for it. It's a rectangular prism as well. So you could have given any one of these answers and you would have been correct, right? A rectangular prism as well as a cuboid. You can't just say prism. You have to be very specific. It's a rectangular prism because all the faces are rectangular. Right, very good. Let's go to the B part now. So now, as you could see, we're increasing in the level of difficulty in terms of how we have to be thinking now. So let's look at this. So it's going to be building this rectangular prism, or you want to call it a cuboid. Now, how many 2x2 by 2 blocks are needed to complete layer 1? So you want to look at layer 1. Layer 1 is the bottom layer, right? If I should mark off the bottom layer for us, like for example, the bottom layer is going to be marked off like this, go around and come back around. And we want to know how many would be needed. Remember, this diagram is not drawn to scale, so don't try to look at it and try to guess it. You can't look and guess. It's going to be pure mathematical measurements that we're going to be dealing with here. You can't look and know. So we're saying that, listen, what's going to be that bottom layer? That bottom layer, how many would take up that bottom layer based on the measurement of the cube that he has in the beginning, and now this new thing that he wants to create? Do not guess it, right? So you're going to have to think. So now, in terms of the level of creativity, now you're going to have to put in that in your thought process as we go forward. So let us take a little time to look at this. One of the first things that you want to know that bottom layer, there are two ways you could do it, right? You could look at the volume for the bottom layer, right? You could look at the volume for the bottom layer. Let us think about this. We're going to think about the volume for the bottom layer. So the bottom layer, right? If I should take it aside, I'm going to do something beside it. The bottom layer will have a 4x20, but it's going to go up by 2, right? Because remember, the cube is 2 centimeters high. So the bottom layer, this is like the bottom layer. So this is my bottom layer, right? So the bottom layer is going to be a 4x20, but by 2, going up 2 in the here because the cube is that tall. How many of them would have fit there? So what you can do with this, all right, I see some good answers coming out. What you can do is to find the volume of this and to drop the volume of this cube in it. So there are two approaches. So let us take the approach 1. All right, so there are many solutions, So solution 1, what we can do, let me put it, I won't be able to work it where it is. Maybe I could pull this down a little bit. All right, let's pull it down a little bit. All right, maybe. All right, let's pull it down a little bit. So based on the understanding that we have, right? Based on the understanding that we have, let's put out solution 1. So I'm going to call this solution 1. So in solution 1, I want to find the volume for the bottom, just the bottom layer. And so the bottom layer, just helping out in terms of understanding what's going on. The bottom layer volume, right, is actually a 4 by 20 by 2. That's the bottom layer, So 4 by 20 by 2. So if you multiply all these numbers, you're going to get about 160, right? 4 by 20 by 2. 4 by 20 by 2, that's 160. All right, so this is 160 cm cube, right? That is the volume that needs to be filled. But remember that one of the little box, one of the little cube is 8. So you want to divide up this by 8, right? So if we now divide this by 8, one of the cube is 8, So if you divide this 160, so watch this now. If you divide 160 by 8, and this 8 is for the cube, because remember the cube is 2 by 2 by 2. The cube that you need to use to fill it is 2 by 2 by 2, which is 8. So you want to divide it by 8. And if you do that, you realize that one of your answer is like, oh, I get 20, right? Very good. The answer is 20. You need 20 cubes at the bottom alone. So that is solution 1. Very good, 20 cubes. I like to give various ways to solve the problem. So I'm going to look on solution 2, right? So let us look on solution 2. Solution 2, one of the things that we could look at as well is based on this, we could look at the bottom of the cuboid and the bottom of the cube, and we can use the two bottoms, right? For example, not the full layer. You don't have to even use the full layer. So solution 2, I could look at the 4 by 20. I could look at the 4 by 20 here. And I could think about 4 by 20. And I want to put, so this is 4 by 20. And if I want to lay this out with 2 by 2, the bottom is going to be 2 by 2, 2 by 2, right? So if I have 2 by 2 here, if this is 2 by 2, then I'll have 2 set going that way. But how many will I have to go that way to get 20? I'm going to have to go all the way down, about 10 sets, all right? Because this is 2, and then 2 more, then 2, then 2, and I'll continue. If I do like this, I'll end up I'll get about 10 sets of 2s going that way, all right? We'll end up with about 10 sets of 2s coming like this, the bottom, if I'm looking at that alone. But in terms of math, what I could do is to take the bottom and divide the two of them. For example, watch this again. Just giving another way out. 4 by 20 will give 80 in terms of the area. All right, so 4 times 20, that's 80. And then if you look at the cube, it's a 2 by 2, that is 4. So imagine that you put this 4 into the 80, you'll get back the same answer again. So we're talking about, if you look at the bottom surface, this bottom surface here, if you imagine finding the area of that bottom surface, right, you would have gotten 80 for that. So that 80, and if you divide it by the bottom surface of the cube, which is 4, you still will get back 20 cubes that are needed to actually fill out all of that. So there are various approaches that you can look at, but bottom line is you will actually end up getting that 20, right? So the B part now, let's jump on the B part. So the B part now says this. How many of this cube will completely fill the block? We just did that, so we got the 20. We work out the 20 up here, guys. So these questions were answered right there, 20. Now let's look now. How many of these blocks that you need to complete the entire thing? How many will you now use to complete the entire thing? Now, what you want to do is to basically look at the volume of, there are more than one ways you could do it, by the way. There are more than one ways, all right? So one of the ways that you can do is to say, all right, the cuboid volume. The cuboid volume is going to be a 4 by 20 by 6. So if I find the volume of the cuboid, I'm going to get 480 cm cube. So if I want to know how many of these would have fit, right? Remember, this has a volume of 8. This has a volume of 8 cm cube. So basically, I want to know how many 8 cm cube can fit into that. So basically, we could say the 480, and you want to divide that by 8. And that's one of the approaches as well. You could have done it like that, and you're going to realize that, oh, it's going to take me 60 cubes to actually fold the entire thing, all right? 60 cubes. 60 cubes, all right? So that's one approach. And you could do it another way too, you know. Let us look on a second way that we could have done it, all right? Let's look back at another solution to get the same 60. Let's clear this up. We're going to try to get the same 60 by our reasoning, right? Remember that we just decided that first layer is 20. Second layer will be 20 again. Third layer will be 20 because there will be 3 layers because you're going to go up to 6 and each layer goes up to 2. So by the time you finish 3 sets, you're already at the top. From bottom to top would have been 6 centimeters and it would have been 20, 20, and 20 again. So another approach to end up getting the total. Each layer would have gone around, another layer would have gone around, and by the time you're finished, you would have been right on top with all of those cubes coming out. So technically, you're seeing that there are many ways you can solve these problems, but you'll still end up with the same 60. All right? So the bottom line is you take your time and you work these down. Now, we're going to go to the part C now. Now, part C is going to, you know, probably go into a little bit more details, as you could see. So part C, it says that Nikai wants to wrap, right? Nikai wants to wrap the block above, right? Nikai wants to wrap where the is missing, the block above. However, he needs to know the material, right? The total amount of material he needs. All right. So calculate the total surface area of the block above. In other words, then, let us say that he wants to wrap this and he doesn't want to waste any of the papers. He doesn't want to go and buy too much paper. He wants to wrap it and let it wrap neatly and just cover the surface. This question is saying, find us the total surface area. Now, when you're doing questions like these, right? For total surface area, you want to make sure that you are seeing the surfaces, understanding the surfaces that you have, be able to find all the surfaces. Now, first you want to pull this apart, right? If you should pull it apart, basically looking at it, you're looking at 6 faces like the cube, 6 faces like the cube, right? And remember though, this 5 that you see here is still 5 here. Oh, this should have been 6. Hold on. This number here is 6. So let me fix it. I think that was a typo right there. This is 6. All right, let me put it back. That was a 6 right there. This was a 6 centimeters. We know that, all right, based on the question. All right, so we're saying here that you want to find the area of all the surfaces is 6, but every surface actually has a twin, you know. Every surface of this cuboid, watch this. This one at the front here, this big broad one at the front, it has its twin around the back. It's at the back. All right, it's still at the back. And if you look at this one at the side, this little one at the side here, it has its twin at the side here as well. All right. So you realize that if you find them, you are able to double it. You find the twin for it. All right. Again, if you look at the bottom, like this at the bottom here, there is a twin for it at the top, right? So we're realizing that, hey, the same things that I'm seeing there, I'm seeing there. So technically, all I'm gonna do right now is to take my time and just work on these 3 sets and double them. For example, set 1, right? We can talk about it. Set 1 is gonna be 20 by 6. That broad one at the front here, if I should just mark it, this one at the front right there, that's a 20 by 6 in terms of the area of that rectangle. So let's write it down. We're dealing with 20 by 6. And you must agree that it's 2 of them because there's another one at the far end. So you double that. Let's write down the other one. This one at the side here. This is 6. This is 6. Understand? So that means the area of that rectangle is 6 times 4. Remember, the area of a rectangle, length times its width. So it is the 6 times the 4 that will give you this piece here. And remember that there is a twin over here with the same measurement, right? So what are we going to do? We're just simply going to find it and double it. You're talking about 6 times 4, and you want to double that. It's 2 of it. Again, the last piece that we want to focus on is the one on the ground. So let me mark it. Look at this. This on the ground here. On the ground, there's a twin for it at the top. Look at that at the top. There's a twin for it at the top. So if I find the area for this one on the ground, all I have to do, I double it and I'll get the one at the top, right? So let's put it together, right? Let me just pull this across a little bit. So the one at the bottom, it is a 4 by 20 at the bottom. So it's 4 by 20, and there's 2 of them. You can double that. Now, to find the total surface area is that we're finding the area of all the 6 shapes. The only thing is we're getting twins, right? So the total surface area, all right, is to find the 6, all right, the 6 faces. So let's make sure that there is no error. So you're talking about 6 times 20. 6 times 20 is 120. You want to double that. So when you double this piece here, you get 240. All right, so that is for this piece right here, right? That gives us the 240 right there. All right. Now, the 6 times the 4, that's 24. And when you double that, you get 48. So this piece here gives us the 48. So I changed the color so that you could see which give what, right? And then now the last piece, as you could see, it's a 4 times 20, that's 80. And you double that, you get 160 right here. So this piece, when you work out this 80 times 2, you get 160 for that. So we're talking about finding the surfaces, all of them, but the good thing is we have some twin surfaces here, all right? So what we're gonna do is just to add up these numbers. We wanna add up 240 plus the 160 plus the 48. We wanna add up all of these, right? So when you add up all of those, then you have the area for the entire thing. So this is gonna be a 8, sorry, I wrote 4. This is 8 right here. This is gonna be a 4 and another 4. So we're talking about the total surface area of this block, right, is actually 448 centimeter square. And you have to put it, remember the unit now, because we're dealing with area. So this is now a square unit I'm using there, square unit, because it's area. So you have to pay attention to the units that you're using in response to the questions that we got. So the total surface area, all right, the total surface area, as you could see right now, is 448, right? Make sure you double check so you don't make errors. You can't afford to make errors when you're going with these calculations. So there it is now. Watch this now. So Nikoi actually would need that amount of paper. So the paper must be measured that amount that he will be using to wrap this new shape. Right. Now, here comes the next part. The next part says wrapping paper is sold at $5 per square centimeters. All right. How much will it cost Nikoi to wrap his block without leaving over any paper? In other words, they are saying, how much will it cost him just to use the exact amount? So he's not just going to go and buy things and come. No, he's going to buy the right amount just to wrap it so there's no leftover. So you're talking about 448. All right. This is the amount of paper that he needs. Right. And then it's $5 for every one. See there, $5 per centimeter cube. So you're going to have to multiply this by 5. You're going to have to multiply this by 5. All right. Multiply this by 5. Take out your multiplication skills. And this is going to cost him $2,240, right? He's going to spend based on the cost for the paper and the amount of paper that he need, $2,240 would be needed to wrap the entire thing. So that is basically the first task, as you could see there. Look at how they normally develop the questions in that sort of format. You want to take your time, work through it, looking back each time, following the instructions, try not to make any errors as you go, right? And all of these questions, as you could see, they are real life situations that you're going through. All right, let's look on the second task that we're going to do. All right, the second task. Let me remind everybody that's here now, please hit likes, like the video, everybody, hit likes and subscribe to the channel if you have not yet subscribed to Daily Maths Concepts, right? Check out the videos as well. There are some videos there for you. They were done specifically for you, for PEP. All right, let us go to this next question. Let's see what's going on. It says here that we're talking about school supplies, all right? So this one is about school supplies. And it reads, students will solve a series of problems regarding supplies needed for classroom using the 4 operations with numbers and decimals and hundredths and so on and so forth. They will then be asked to look at 2 ads for local stores and, you know, stuff like that. So they're giving general information here. Normally you read this and then you go on by doing the task one by one. Take great consideration as it relates to all the little tasks that you're doing here. All right. So let's read the first one now. So this is where it is. The first part of it was just telling us that, hey, you're going to be dealing with some school supplies. And as you could see, this one is going to be about pencils and pens and students. All right. So part 1. So I'll read. This is what it says. It says here that it's the beginning of the school year and time to get supplies for the classroom. Mr. Burton has ordered some supplies for his students and is wondering if he has enough for 32 students. So definitely we're told here indirectly that he has 32 students, right? So he ordered some stuff. He's wondering if he has enough for his 32 students. All right. Now, the first task says Mr. Burton ordered 512. He ordered 512 pencils. However, how many pencils will each student receive? Right? Show your working by writing a mathematical sentence or drawing a model or calculation. So in whichever way suits you best, they are saying, listen, should you show us So the main thing here, it says how many pencils will each student receive. So you're talking about total pencils that he has. He has 512 pencils. Now, the number of students he has, he has 32 students dealing with, right? So we're talking about he has 32 students, he has 512 pencils. How many will each get? So a quick mathematical statement is that you need to divide, right? You need to divide. So you want to divide the total, just writing this, the total pencils. If you divide that by the number of students, if you divide this by the number of students, then you're going to get how many each, how many pencils each student gets. So you would have known that. You want to know how many pencils each student get, you want to divide the total pencils by the total number of students. So as you could see, I'm seeing some very good answers coming out. So it's going to be 560, 512. You want to divide that by 32. You could take your time, you could cancel down, do your math. You're going to end up with 13 pencils. 16, I should say, pencils each. Let's go again. You're going to get 16 pencils each, right? So as you could see there, very good going. I'm seeing some nice answers coming out. Very brilliant set of students here logging on. All right. So we're talking about 16 pencils each of them would have gotten right there. Now, let's go again. There's another. It says, Mr. Burton, order 12 boxes of ballpoint pens, and each box contains 12. So he ordered 12 boxes. You have to highlight the important details. Each box contains 12 pens. So the question is now saying he would like each student to have 5 pens, right? He would like them to have 5, right? Did Mr. Burton order enough boxes? Did he order enough boxes? Explain why or why not, right? So they want you to tell, did he order enough boxes? There are 12 in each. He has 512 students. He has 32 students, and you want everybody to get 5. One of the things that you want to look at right now, you want to look at 2 things, all right? So you're saying 12 boxes, right? With 12 in each would give a total of 12 times 12, and this is 144 pens, right? So it means that he ordered 144 pens. So we could actually put this here. 144 pens were actually ordered, right? Now, another point of information is that he wants each to have 5. So you're talking about 32 students. That's, he has 32 students. You want to multiply that by 5 to see how many he really need, right? So he really needs 32 times 5. He needs 160. So he actually needs 160 pens are needed, all right? So what we did here, we just simply put together his requirement and put together what he got. So looking at the 2 numbers here, you already see that there is a problem because he only ordered 144. Nevertheless, based on the conditions that he has for himself, he is now short. right? He is short. He is short by about 16, right? So in response to the question though, so this is our calculation. So now we can make now a very positive, or we can make an accurate decision right about now. All right. Question. Here's the question. Did Mr. Burton order enough boxes? We could say no, right? So no, he did not order enough boxes. And how you know? Explain why. Because 12, you could do a number of things. You could say, well, he needed, I'm just gonna write this, he needed 160 pence, but he got 144 instead. So I could just give that as the argument. So no, he did not order enough because he needed 160, but he got 144. So we're seeing right here, we're explaining that. And there are other ways you could explain it. It's up to you to use your own words to actually articulate how you want to come up. But the bottom line is you want to let them know that he was short by 16, right? He ordered less than what he needed to facilitate those students in the class. Again, I'm reminding everybody to hit likes on the video. Everybody hit likes. I'm seeing 106 of us here. I'm expecting to see 106 likes, right? And those who have not yet subscribed, do that. Now, going down to more, some little more details now. All right, so looking at this section now, right? It says Mrs. Armstrong and Mr. Tank, all right? The other two fifth grade teachers wants to share the supplies with their classes as well, right? Unfortunately, they didn't order nearly as many pencils and pens as Mr. Burton. All right, so they didn't order enough, but they still want to share. So they're going to come up with something. So the question says here that they decided to put all of their pens and all of the pencils that they were ordered together and divide, all right, the pencils between, so we're focusing on pencils here, between the three classes evenly. All right, this word is nice, evenly. Each class has the same number of students, okay, and there are 1,152 pencils. 216 pen, but we're focusing on pencils for now. All right, so you're talking about three classes, and if all of the classes would have the same number, remember that Mr. Burton has 32. So 32 times 3 is going to tell us now that there are 96 students that we're dealing with. When we combine the other two fifth grade teachers' number of students, and because the question said that it's the same amount in each class, then now we have good argument to say that we're dealing with 96 students. Now, the question really says here, how many pencils each child get, right? So now we know the total pencils. Let's write it, the total pencils, right? Total pencils. Total pencils. That's 1,152. So if we want to know how many each of them would get, well, all we're going to do now, we're going to just simply work our division here. 1,152, you want to divide that by 96, right? You want to take your time, you want to cancel down whichever way you're used to. Take your time, you will get 12 pencils each. All right, so you would have gotten 12 pencils each. Very good, Adna Star. I see you coming up with your 12 there. All right, all right, all right, very good. All right, all right. So we employ division there, and reading of the question is definitely important and picking up clues from the question. So you see this nice little paragraph that you get here was nicely put with every single clue that you need. And even things there that you do not need right now, but you're going to be needing it as you go to the other questions. So in this case, you realize that now everybody is getting 12 pencils. Compared to the beginning, everybody from Mr. Burton's class would have had about 16. But based on the fact that they have to share up, everybody is now getting 12 pencils. All right. So this part now says, how many pens will each student receive? All right. So you want to go back here to have an idea of how many pens they have in total. So you're not guessing it, you know. Remember that he had 144 pens from the beginning, but here it's telling you how many pens that were actually there in total. So when everybody combine their resources and everything, we're talking about having 216 pens this time. So let's go down there with 216. Let us put it together. All right. How many pens will each student receive? Remember, they're talking about, they did say they want everything to be shared up equally, right? So that's the word, equality, dealing with division. We're talking about 216 pens, right? And if you want to share this up equally now, and I want us to understand that this is not like cake where I could give a quarter of a cake, right? We cannot give a quarter of a cake and stuff like that. We can't give half. What I mean, this is not pens, this is not cake. So we're talking about pens. You can't say you're gonna give somebody a quarter of a pen. All right. So it's not like you're gonna break the pen and give somebody half of a pen. That's not it. All right. So we need all numbers here. So if you have to work this out, and give the whole number, you're fine. But I'm certain that if you're gonna share this up equally, we cannot get or give certain numbers logically. We're talking about pens, right? So if you divide this by 96, you know, if you divide this by 96, you might get 2.25. But can you really give somebody a quarter of a pen? Let's think about it. Can we give somebody a quarter of a pen? I refuse to agree with that. So now we're going to have to put it together. There will be some left over, but fine. But if we're going to give everybody equal amount, and it's pen, we can't have quarter of a pen, right? So basically, you will see that, I think, based on what we have here, if you have 96 and you multiply it by 2, based on the number that you're looking at, this will come up to about 192. So this would have taken away 192 pens, right? So there's 192 pens. Everybody get 2. So each can get 2 equally. Everybody get 2. But I won't go a decimal for a pen. All right. So we're talking about each student's will get 2 pens. And that's the reality. If they're talking about equal, the moment they said equal, I can't do anything else because I won't be able to divide the remainder. If you look at the remainder, it's about 216 minus 192. There will be about 24 pens leave. And I cannot share up 24 pens for 96 students. All right. So yes, we have leftover. That's fine. But we are focusing on equality and how many they would get when it is shared up equally. 2 pens each they will get. There will be leftover. Well, Mr. Burton and Miss and the other two, the 3 teachers could keep 8 and keep them in their storeroom until somebody pen is finished. But definitely we're gonna settle with 2 pens each based on the context. Pen cannot be in decimal, and we want to appreciate that right now. Pen cannot be in decimal, so we won't submit a decimal number for the number of pens. Explain how you know this is correct. We just spoke about it because we're saying pens, we cannot have, I'm going to put here a quick explanation that we cannot have a decimal value for the number of pence. We know that. Can't have a decimal value for the number of pence, right? So that is why we're not just going to run away with the 2.25. No, it's going to be 2. Everybody will get. And we are explaining to the examiner that, listen, I can't have a decimal number for pence. All right, pen has to be a whole number. I can't break the pen and say you get piece of the pen. All right. So that's the way forward, right? The way forward as we go. All right. Let's go in now. We're coming down. This is not a long session. Not a long session. We're coming down. All right, coming down. All right. Now, the last task says that if the pens come in boxes of 6. All right. So now they are saying if the pens comes in boxes of 6. Here it is. The pens now come. So this is an if case. All right. So forget about Mr. Burton. It's sets of 12. This is if the pens comes in boxes of 6. And we're talking about 216 pens right now we're focusing on. 216 pens. So if they actually came in boxes of 6, how many boxes of pens were ordered? Right? How many boxes of pen were ordered? Write a mathematical sentence for how many you could, what? Write a mathematical sentence for how you could solve this. Okay. So I mean, we're simply, so they want to take the love when you write a mathematical sentence. See, a mathematical sentence is simply a statement of truth as it relates to what you have here. So look at what they want, look at the details that you have, right? They said if the pen, so we're talking about in boxes of 6. So you know that you're going to divide up this by 6, right? How many boxes of pens were ordered? All right, so boxes, the number, that's my number sign, number of boxes of pens ordered will equal to the total pens. And you want to divide that by 6. All right, and in this case, it's 216 pens. And you want to divide that by 6. And I believe you're going to get 6 in. That's 6. I mean, 36. All right. So 216 divided by 6, and you're going to get your 36 boxes, right? So in this case, based on this if situation, they would have ordered 36 boxes, and that would have given them 216. So your mathematical sentence has to be a statement of truth, no biggie. Look at what they have and take your time, walk yourself out of the situation right there. Let me see if there's another part to it. All right. So there are 36 boxes that were ordered. Very good. Right. Now, the last part, I believe that this is the last part. This is the last part right there. So it says here that if the boxes cost $2 a piece, all right, how much did they spend on pens? Show you're working using one of the property of multiplication, right? So you're definitely seeing that you're talking about 36 boxes, right? And each costs $2, right? So you want to show that, listen, I'm going to multiply my 36 by 2, right? Each box is costing me $2. So you multiply your thing, you get 2 6s, 12, carry a 1, 3 2 6 and 1 7. So $72 was spent on pens right there. All right. And that's where we are at the end of the road. All right. So very good, very good. So you have to think, you have to take your time, work through. All right. So as I said to you, this one was just a 1-hour session, and we are at the end. And it's very good. Give some shout outs, guys. Give some shout outs. Give some shout outs right now. Is the time for you to shout out all of those who you want to shout out right now in the chat. Remember to like the video right now, right? Please like the video. And if you have not yet subscribed to Daily Maths Concepts, now is the time for you to do so. All right. So let us just give some shout out to all your teachers, all your friends right about now. And our session is coming to a close. All right. So it was nice having you guys for class. All right, guys. So until then, we'll see you next time. And we're gonna do one of these workshops every other week. So not next week, the week after, we're gonna do another one. And depending on which exam is coming up, the classes that we do here will be like that. So the nearest exam, that's what we're focusing on. Thank you very much for coming out, and I'll see you guys